In this video, we will talk about how to find the area of a regular polygon given the radius. So let's say that we have this hexagon here, and we're told that the radius has a length of 9 centimeters. How can we find the area? Well, the trick is we need to use this formula right here. The area is equal to 1/2 times the apothem times the perimeter of the figure. So the apothem is the distance from the center to the midpoint of one of the sides. So this would be the apothem. So let's label that A. So the trick is we need to split this hexagon up into congruent triangles. So let's split it up into 6 congruent triangles since there are 6 sides on the hexagon. And what we can say is the sum of all of these central angles of each of the triangles must add up to 360 degrees. So we can easily find the angle of just one of these triangles by doing 360 divided by 6. So what is 360 degrees divided by 6? That is 60 degrees. So this red angle right here is 60 degrees, and the apothem perfectly splits this angle in two. So half of that angle must be 60 degrees divided by 2, which is 30 degrees. So we can label this little angle right here 30 degrees. So if we notice, this is a right triangle right here. And if we have one angle and we have one side, we can figure out the other sides. So let's start by figuring out what is the apothem. So if you'll recall from trigonometry, the acronym SOHCAHTOA, the cosine of an angle is calculated as the adjacent side over the hypotenuse. So we can say the cosine of 30 degrees must be equal to the adjacent side. So the adjacent side is this A right here, the apothem, divided by the hypotenuse. So the hypotenuse of this triangle has a length of 9. So we'll write 9. So we can figure out what A is by doing 9 times the cosine of 30. So let's say 9 times the cosine of 30 degrees is equal to A, the apothem. So if you punch this into a calculator, you'll find that this is roughly equal to 7.8. So the apothem is 7.8. Now we just need to find what is this side of the triangle, because once we find this, we can double it to get the side length, and then we can multiply by 6 to get the whole perimeter. So if we call this side length x right here, we can say that the sine of this angle, the sine of 30 degrees, is equal to the opposite over the hypotenuse. So we'll say the sine of 30 degrees is equal to the opposite side of this angle is the x right here. So we'll say x divided by the hypotenuse, which again is 9. So now we can solve for x by multiplying both sides by 9. So we get 9 times the sine of 30 degrees is equal to x. And if you punch this into a calculator, you'll get about 4.5. So 4.5 is equal to x, this side length right here. But we want double that since we want the full side length of this hexagon. So 4.5 doubled would be 9. So we'll say the side is 9. But remember, we have 6 total sides of this hexagon. So the perimeter all the way around would be 9 times 6, which is 54. So we'll say P, the perimeter is 54. So now we have both P and A, so we can figure out what the area is. So I'm going to make a little room here. Okay, so we found that the apothem is 7.8, the perimeter is 54. Now we just need to plug these into this formula for the area. So we'll say the area is 1/2 times the apothem times the perimeter. So if you punch this into a calculator, you'll find that the area is equal to about 210.6. And remember, we said the units is going to be centimeters, so we'll say centimeters squared since we're talking about area. So this is our final answer. This is how we found the area of this regular polygon using only the radius.